Okay, so this P of O can be written as summation of P of O comma Q and iterating on Q. Right, so this P of O Q will also be a similar kind of matrix, observations and states, or the states here, observations here and states here. And this P of O comma Q can be written as summation on Q P of O given Q dot P of Q. Right, so this can be again written as, when we expand this, it is P of O1 given Q1 dot P of Q1. Right, so since we are iterating on Q, so it will be actually all sequence of states. So that will be P of O1 O2 dot 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 O of T given Q1 Q2 dot 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 Qt dot P of Q1 Q2 dot 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 Q of T. And each of these states Q will be having some of values. So like each of this Q1 will be having either high or low. So this Q1 up to Qt, this Q1 Q2 dot dot dot, this Qt will be sequence of, actually it will be something like this. It will be having lot of values here. So there will be combination of T values with respect to n states. Right, so if this is having n values, if Q1 is having n values, that is hot and cold, that is n is equal to 2. So it could be like hot hot hot, then hot hot, cold hot cold hot, and so on. So for this particular, this given equation, we will have n to the power t combinations of this kind of hot, cold, and on and so on. So if it is hot, medium, cold, then the number of combinations will be more. Right, so for our example, P of 3 1 3 this P of 3 1 3 can be written as P of 3 1 3 comma hot hot hot. So since this is summation, again we will plus on another sequence of states 3 1 3. So another sequence could be cold cold cold, and so on. So in this way we can have, in this particular example, we can have 8 combinations. So because n is equal to 2, n to the power t is actually equal to 2 to the power 3. Right, so we see here that is a very large number of these parameters that is required to calculate. Okay, so for this small sequence only of time step 3 is having 8 observations that has to be done. Sorry,
स्क्रीन नहीं दिख रहा है.
स्क्रीन नहीं दिख रहा. अच्छा, ओके, सॉरी. Okay, so with respect to this, P of O given Q is equal to P of O comma Q is equal to P of O given Q dot P of Q. We can write P of O is equal to summation on Q of P of O comma Q. So this can be done by a law of total probability. This is actually the law of total probability. When we are having a joint probability between A and B, we can calculate the probability on A by summing up the probabilities on B. So if this is the table of A and B, then we can sum up all the probabilities along with the values on which B is changing, and then we can get the value on that A. So in this way we can reduce a two variable probability into a single variable probability, right? So P of O can also be written in the same way as P of O comma Q summation on Q, and this P of O comma Q can be written as P of O given Q dot P of Q, which can be again written as in its expanded form as P of O1 O2 dot 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 O of T given Q1 Q2 dot dot Q of T dot P of Q1 Q2 dot dot Q of T. So here this is summation on Q means that, so this Q1 Q2 Qt will be a sequence of states. So this has to be iterated on all the possible sequence of states. This is again on Q. So in our example, P of 313 can be written as P of 313 comma hot 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 plus P of 313 comma cold cold cold, and in this way it can be written with 8 combinations, and then this can be again expanded P of 313 given hot 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 dot P of hot hot hot, right? So we see that this way of calculating the sequence is not workable, not practically possible. So we need to require to do some kind of apply some kind of method that is having much less computation, right? So in this diagram we see that we are having the same sequence, the same hidden Markov model, and this is the start point. From here we can start, and we can have, there are two possibilities of states, right? So we can move this way towards the hot state, and we can move towards the cold state, right? From here again we have two possibilities. From hot we can move towards hot, and hot we can move towards cold, and again from cold we can move towards hot, and from cold we can move towards cold, and so on, right? So we see here that lot of possibilities can be reduced by propagating the sequence in this way. So this algorithm is actually called as the forward algorithm, and at each of these sequence we can calculate the probabilities, right? So if I am going on this way, I can calculate the probability P of hidden, P of hot given start dot P of 3 given hot, right? So this arrow is representing the transition of start towards hot, right? So that's why we are having P of hot given start, and then hot is the current state, and the observation is 3 here. So we are having the P of 3 given hot. So in this way, for each of these arrows we can write the probability. Similarly, in this way we can write the probability of the transition probability of P of hot given hot, and the observation probability as P of 1 given hot, right? So now we can do is that for each of these nodes we can define a function that will tell us the probability up to that node. So we can define a function like this. So this function will tell the probability up to this h. This will tell the probability up to this one. Similarly, and up to this through all the possible paths. So for for this one, for this state H, I am having this possible path and I am having this possible path. So these two paths will be required to be added in order to get the required probability. Right, so that means there is this path, one path, path A or path B, right? So we are having these two paths, and the probability of these two paths will be added together in order to get the total probability, right? So we can call this function, we can write down it in the form of each node in the form of a function. So this function can be written as alpha tj, alpha suffix t and j, right? So what is this alpha tj? So it represents the probability of being in state J after seeing T observations. And given y, that is the original hidden Markov model probability tables, right? So alpha tj, I can write alpha tj is actually the sum of probabilities that could lead to a given particular cell. So which is that cell? The cell of state J and time step T or observation T. The cell with state J. So this is the alpha tj, this is the state. In bracket I am writing the state J. In bracket I am writing the state J, and I am getting the observations as suffix, right? So this is observation 1, this is observation 2, and this is alpha 3 2, right? So I can write this alpha 1 h also, alpha 1 something like that. So since there are two states, two possible values of each state, so I may be having alpha bracket 1 and alpha bracket 2, and I am having T observations. So alpha suffix 1, alpha suffix 2, alpha suffix 3 up to T we can have. So we are having only 3 observations. So we will get the values as alpha 1 1, alpha 1 2, then alpha 2 1, alpha 2 2, alpha 3 1, and alpha 3 2. In this way we will be getting, and we will be calculating all these recursively. Let us see how. So I can write this alpha tj as actually the probability of P of O1 comma O2 dot 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 up to O of T, right? At alpha T I have seen T observations, right? And I am on state Qj, right? And Qj state is actually represented by the J here, J variable given lambda, right? So now this has to be written with the help of alpha t minus 1, right? So I may again write this, explain this as alpha tj is means that the tth state, in the sequence of states is state j, right? So that means this tth state is corresponding to state j. So now this can be recursively written as alpha tj is equal to alpha t minus 1 I a of ij b of j ot and summation on I is equal to 1 to capital N, right? Where alpha t minus I is actually the just previous forward path, forward path probability from the previous step, right? So we are writing this alpha t minus I as aij bjot. So aij bjot, this is actually the combined probability. This is actually referring to the probability of up to observation OT, right? Up to observation OT on state J, right? So aij, we all know that it is the transition probability, and bjot is the observation likelihood, right? So this is the transition probability, and this is the observation probability, right? So alpha tj can be written as I is equal to 1 to n summation alpha t minus 1 I ai bj ot, right? And this we are doing for any states. So we here we are having two values of states, so this we will be doing for two states. Right? So if we need to calculate, let's see here, if we need to calculate this alpha 2 right? So for alpha 2 we will be requiring this alpha 1 and alpha 1 right? We have this alpha 1, so this is t of I minus 1 and we are iterating on I, right? So this is alpha 1 is I minus 1 and we have to iterate on I alpha t minus 1 and we have to iterate on I. That means we have to sum this alpha 1 and alpha 1 multiplied by this one and this one, right? So this is multiplied with this and this is multiplied with these two probabilities are multiplied. So in this way, when we add these two, we get this. So this is 0.32 multiplied by 0.6 multiplied by 0.2, then 0.02 multiplied by 0.5. It should be 0.5 multiplied by 0.5. So that is P of H given C, P of 1 given H, right? So there may be some kind of typo here or here. यहाँ पे typo होगा या यहाँ पे होगा, right? So in this way we can calculate alpha 2, right? Alpha 1, 2 can be calculated in the similar manner, right? We are having only, since we are having only one starting state, so this alpha 1 is actually the starting of the function, right? So we just we multiply P of H given start and P of 3 given H. So we can write this in the form of an algorithm. We can write some steps. Number 1 is initialization. So initialization is alpha 1j. Alpha 1j is directly initialized by A0j bj O1, observation 1, right? It is directly initialized with the help of observation 1. Then second is the recursive expression, that is the recursion. So in recursion we write alpha tj is equal to summation I is equal to 1 to n alpha t minus 1 I, right? And then A ij b j o t. So we multiply all these three terms, and then we have 1 is less than equal to j is less than equal to n, and 1 is less than equal to small t is less than equal to capital T. So these are the number of sequences, and these are the n is the number of states. And then we can terminate P of O given y, that is the hidden Markov model, or in previous classes we saw P of lambda. So that is alpha capital T QF, that is the QF is the final state, that can be written as summation of I is equal to 1 to n alpha t I ai and final state, right? So from final state we don't have any observation, right? So in this way we can calculate the probability of up to t time steps for a given observation. So here we are having 3 observations, that is 3, 1, 3. So we can calculate the probability of this sequence 3, 1, 3 as O1, O2 and O3. And then this can be written in an algorithm form. This is the algorithm. So here in this algorithm we are using the notation alpha T S is represented by the function or the array forward. Forward S comma T. So this forward S comma T is a kind of a double dimensional array that is every time is storing the calculation of probabilities, right? So for initially it is doing it for the first state, and then it is again doing recursively for all the states and observation, and then it is calculating it for the final state. So in this way we can calculate the probability of a given sequence, right?